Hey guys, Mr. Jorgens here. We're going to go over section 2.2 today on linear inequalities. It's going to be solving one-step linear inequalities with addition or subtraction. Should be very similar to the one-step equations that we worked on in chapter 1, except we're going to have to do a little bit of graphing that we talked about for the first time in 2.1. Hope you're ready. Pay attention. There's going to be a couple questions for you along the way. All right, here we go. The first example we're going to look at is x subtract 5 is greater than 2. So again, x is a placeholder. We're looking for some number that when we subtract 5, the left-hand side will end up being greater than 2. We kind of worked on this with equations, and the first thing we would do is try to guess. So in this case, if it was equal sign, we would say 7 minus 5 equals 2, and we'd know that 7 has to be our answer. But in this case, you should realize there would be multiple numbers for x that would work, right? Because there's many different numbers that would make the left side greater than 2. It could make it 3 or 4 or 100 or 1,000,000, right? So take a second, pick which of those options in the answer key here would give us an x that when we subtract 5 from that number, the left-hand side would be greater than 2. All right, now that we've thought a little bit of what the number is going to mean as a solution, let's go about trying to solve it by a process of inverses. Now, we should have learned in chapter 1 that whenever we're trying to solve for x, we're going to undo operations with their inverse. And in this case, I have subtract 5 or subtraction stuck to x, and the opposite of subtraction is addition, in this case by 5, right? So I'm going to add 5 to the other side, and then I get x, and 2 plus 5 makes 7. So x greater than 7. And what that means is that any number that's bigger than 7, if I picked it, the left-hand side is going to make something that's greater than 2. For example, if I picked 8, 8 minus 5 makes 3, which is greater than 2. Or if I pick 10, 10 minus 5 makes 5, which is greater than 2. So any x value that's greater than 7 is going to end up making that original equation true in the end. So I know that my answer is x is greater than 7. Now, this is a little different than equations because we have multiple different numbers that work. So rather than listing all the numbers like 8, 8.5, 8.6, 9, 10, 1,000,000, we are going to draw it on a graph. We can draw it kind of on a number line, and I'm going to center my number line at 7 since that's our key number here. Bigger numbers like 8, 9, and 10 go to the right. Smaller numbers like 6, 5, and 4 going to the left. So I have kind of a snapshot of a number line here. Now, from last week with the graphing, we should have learned that greater than and less than is going to mean an open circle. Greater than or equal to or less than or equal to is going to mean a closed circle, right? So in this case, I don't have or equal to, I just have greater than. So I'm going to draw an open circle at 7. And I know I want the numbers that are bigger than 7, like 8, 9, 10, and so on. So I'm going to draw my arrow toward that right-hand side. And that'll show you a graphical display of our solution set x is greater than 7. All right, it's time for us to look at a second example here. X plus 8 is less than or equal to 5. Now, as we go about solving this one, we should realize that in this case, instead of undoing subtraction like I did in example 1, I'm going to be undoing addition in example 2. So section 2.2 is all about undoing one-step inequalities where I have to undo either addition or subtraction. If I have a problem like example 1, I'm going to be undoing my subtraction by adding. In this case, I'm going to undo my addition by subtracting 8 off of both sides. And when I do that, on the left I get x, and on the right I get 5 subtract 8. So 5 subtract 8, I could do that with a plus minus chart. Really quickly solve that one out on your own. 5 subtract 8. So I've got a plus minus chart there for you now on the right hand side. 5 positives and 8 negatives. I have more negatives, and there's 3 more negatives than positives, so it would be a -3. So my answer that I'd be left with would be x less than or equal to -3. Now, on all of these problems for inequalities, I'm going to end up drawing my graph as a part of the solution because I want to show all the numbers that work, right? I don't want to just say that -3 is the answer because in this case, negative 3 is a solution because negative 3 is less than or equal to negative 3, but it's not the only solution. There's many different numbers that would work, where if I plugged it in for x, that x would be less than or equal to negative 3. So some bigger numbers than negative 3 are negative 2 and negative 1. So I'm going to put negative 2 and negative 1 to the right-hand side. Some smaller ones would be negative 4 and negative 5. Again, what I talked about on that last slide is if you have less than or greater than, it's going to be an open circle. If you have less than or equal to or greater than or equal to, it's going to be a closed circle, right? And that's something that we learned in section 2.1. So I'm going to put a closed circle at negative 3. And I want the numbers that are less than or equal to negative 3. Like if I think about numbers that would work, negative 4 and negative 5 are numbers that are less than or equal to negative 3. That would work if I plugged it in for x. Whereas negative 2 and negative 1, those are not less than or equal to negative 3. They do not work. So I'm going to draw my arrow toward the solutions that are going to work here. And that graph would depict my solution set for this one, x less than or equal to negative 3. Go ahead and try this one on your own. Enter your answer when you're ready. All right, let's go through the solution on this one. This is subtract by 6, so I'm going to undo subtract 6 by adding 6. Negative 10 add 6 makes negative 4. You can think about it as a plus minus chart. I have 6 positives and 10 negatives, which is 4 more negative than positive. So I get x greater than or equal to negative 4. When I go to draw that on my graph, I'm going to center it at my key number, negative 4, put 2 bigger ones and 2 smaller ones. Since it's or equal to, again, if I have that line underneath right there, I'm going to put a closed circle at negative 4. And I want the bigger numbers, so I'm going to draw my arrow to the right-hand side. Negative 3 and negative 2 are the bigger numbers in this case. So your solution should be x greater than or equal to negative 4, and that would be a graph that displays our solution set. Here's a second problem for you to try. X plus 5 is less than or equal to negative 3. Go ahead and solve this one out and then draw a graph of it in your notebook, then select the answer option once you're ready. All right, so on this one I'm undoing addition, so I'm going to undo addition by subtraction. So I'm going to subtract 5 off of both sides. In this case, negative 3, subtract negative 5, 3 negatives and 5 more negatives is going to make 8 negatives. So my net result of negative 3 and negative 5 is going to make negative 8. So I'm left with x less than or equal to negative 8 as my solution here. If I want to draw it on a graph, again I have the or equal to underneath. So it's going to be a closed circle or a closed dot at negative 8. Bigger numbers, negative 7 and negative 6, are not going to be less than negative 8. Numbers that are going to be less than negative 8 are the smaller ones like negative 9 and negative 10. So I'm going to draw my arrow in that direction. Hopefully that gives you a good setup of how to solve problems like 2.2, where we are solving linear equations with one step, where that one step is addition or subtraction. That's our main goal for that section 2.2. Section 2.3 is going to be similar. It's going to be the same thing, solving one-step inequalities, but it's just going to be with undoing multiplication and division instead of addition and subtraction. So go ahead and you're ready now to try the big ideas problems on section 2.2. Thanks for listening.